My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 608. In this lecture, we will try to understand receptive fields and effective receptive fields. So this is one of our student query. So he asked for what is receptive field. That's the question. And what is the difference between receptive field and effective receptive field? Again, this term receptive field term that we have not used as part of this lecture series, but I will explain it. The concept behind it, the concept behind this is very simple, that we have already covered in our convolutional neural networks chapter, of course, chapter of ours in the deep learning section or in the deep learning module. So the receptive field, the term receptive field itself comes from, just see this one, the term receptive field itself comes from neuroscience, isn't it? But its applications, this particular term came from neuroscience, but its applications in the context of convolutional neural networks is as follows. Imagine if I have an image like this. Imagine in the very first layer, let me assume in the very first layer, let's assume I have a convolutional filter in first layer, or you have a convolutional kernel of size 5 by 5. Where it is in first layer. Just see, here I have a convolutional, here let me write like this, just say, let me write this one. This is first layer. Let me say this is first layer. In first layer I have a convolutional kernel whose size is 5 by 5, isn't it? Of course, it's a kernel of 5 by 5. Of course, what I will have here is, I will not have just one kernel. I will have in the first layer, I will have multiple kernels like this. That's important. Just say what I am saying. In the first layer, let's assume I have convolutional filter or convolution kernel, isn't it? I will have multiple kernels like this. That's important, isn't it? I will have multiple kernels like this, but let's look at from the perspective of just one kernel. So this kernel, what is the size of this kernel? 5 by 5. So a receptive field. So let me first define this term, then I will discuss about effective receptive field. So receptive field is basically nothing but at any point, just see, here actually I am discussing this with the perspective of single kernel, but I can have multiple kernels like this, isn't it? Just say this one, what it says, what it is, receptive field. So receptive field is basically nothing but at any point, how does this convolution operation work? At any point I will take this convolution filter. What is this convolution filter? 5 by 5 convolution filter or convolutional kernel. I will pass it through various parts of the image. Just see, I am taking this particular kernel, I am passing through here, this I will keep here, and again next here, means what I am doing, I will pass this 5 by 5 cross 5 kernel, I will pass it through various parts of this input image, isn't it? And for each part I generate an output, isn't it? For each part I generate an output. Receptive field is basically nothing but it is that part of the image which the convolutional kernel operates at given point of time. I will repeat, receptive field is basically nothing but, what is receptive field? Receptive field is basically nothing but it is that part of the image. Just say this is that part of the image, which the convolutional kernel operates operates on at a given point of time. For example, at a given point of time, just let me assume, at a given point of time, this convolutional kernel, which convolutional kernel? This particular convolutional kernel, 5 by 5 kernel, will see 5 by 5 bunch of pixels here. Here in input image, it will see 5 by 5 bunch of pixels in the image, input image. Again, these pixels could be colored. These pixels are grayscale. If it is colored pixel, I will have RGB in the tensor. Otherwise, I will just have simple image with the grayscale values. So receptive field. Receptive field of this convolutional kernel, which which convolutional kernel? 5 by 5 convolutional kernel at given time t will be these 5 by 5 section. Just see which 5 by 5 section? This 5 by, this is receptive field actually, isn't it? This 5 by 5 section of the image that is being convoluted using this convolutional kernel to generate one value in the output image, isn't it? Output image. Of course, this 5 by 5 keep changing, isn't it? First I will keep 5 by 5 here, then I will keep 5 by 5 here, then I will keep it keeps changing, isn't it? It keeps changing. At a different point of time, I might have another 5 by 5 region, 5 by 5 region in the image, isn't it? Which will be convoluted with this 5 by 5 kernel, and another output is generated, and the output will be somewhere actually here. First I will convolute this and this output I will keep here, and this and this I will convolute. This output will be in different place, isn't it? So receptive field basically is the part of the image which the convolutional kernel at given time t is being convoluted with. Very simple. Now what is the effective receptive field? What is this effective receptive field? This is slightly more intricate concept but simple. I will try to explain with example, just one convolutional kernel, but example with example of just one convolutional kernel, but in reality I will try to understand with one convolutional kernel, but in reality you will have multiple convolutional kernels, isn't it? Whose weights we learn through back propagation, isn't it? How can we learn weights? By using back propagation. So let's assume I have this this is my input image. I have this convolutional kernel, isn't it? This convolutional kernel again. Let's look at only from one kernel perspective, isn't it? This is single kernel, isn't it? This single kernel will generate an output. Remember, let's assume this kernel is in the first layer. This 5 by 5 cross kernel, where it is? It is in the, let's assume this 5 by 5 cross kernel is in the first layer, and this is the output of the first layer. Which one is output? This one, output of the first layer, isn't it? In reality, what happens? We will have multiple kernels. That's important. What we get here with multiple kernels? What we get here is a tensor. But let's look at it from this perspective, only one kernel perspective. Now imagine I have other convolutional layer. Let me assume second convolutional layer. In my second layer, let's assume let's assume also a convolutional layer where the size of my convolutional, convolutional kernel is 3 by 3. It is in second layer. That is important. In the second stage, now because this is 3 by 3, what happens? 3 by 3 region of this output image. Just say 3 by 3. Here you have 3 by 3 kernel, isn't it? This 3 by 3 region. This is output image, isn't it? Layer 1 output is here, isn't it? 3 by 3 region of this output image. This is the output of the first layer. Which one is the first layer output? This is output. of the first layer, isn't it? Output of the first layer. My original image is in this input layer. This is my original image. This is in first layer. I have original image, isn't it? My original image in the input layer. I must say input. My original image is here, isn't it? This 3 by 3 at any given time, just say this 3 by 3, let me say like this, this 3 by 3, this 3 by 3 at any given time will be convoluted, actually let me say this 3 by 3, let me explain like this, this 3 by 3, just this is a part of output image. Whose output? Layer 1 output image, isn't it? This 3 by 3, which 3 by 3? This 3 by 3 at any given time will be convoluted with this kernel. With which kernel? 3 by 3 kernel, isn't it? Output will be generated. Similarly, at different time, another 3 by 3. Another 3 by 3 here, and this 3 by 3 will be convoluted with this 3 by 3 kernel, and it will be convoluted and it will generate output, and so on, so forth. Now here the receptive field the receptive field in this image, in this output, this one is receptive image. In this image, this is receptive field, isn't it? Image after the first layer, isn't it? This is receptive field. This is receptive field for this particular kernel, for 3 by 3 kernel, isn't it? The receptive field in this image, in this output image, after the first layer, the receptive field in this image, after the first layer means what? Which one is after the first layer? This is after the first layer. After the first layer, the receptive field in this image of this kernel at any given time t is just these 3 by 3 pixels, isn't it? Here you will get 3 by 3 pixels only, isn't it? But the effective receptive field, what is effective receptive field? Is a part of the original image. Which one is original image? Which one is original image? This is original image. This is important. This is original image, input image, isn't it? But the effective receptive field is a part of the original image whose pixels are being indirectly convoluted with this 3 by 3, isn't it? With this 3 by 3. The key idea is this single value is generated here. Value is generated in the output image. These single values are generated by using 5 cross 5 region here, isn't it? 5 cross 5, this 5 cross 5 got convoluted with 5 cross 5 here, isn't it? With this, and this single pixel, that pixel values can be stored here. This 5 cross 5 kernel in layer 1 will be convoluted with 5 cross 5 pixels in the input image, and after convolution you will keep values in this output image, isn't it? Its next pixel was generated. How next pixel will be generated? Again this 5 cross 5. Again I will keep it, I will convolute this other part of 5 cross 5 image, 5 cross 5 part of the image. Again I will store this value somewhere in the output image, isn't it? Again this depends on stride and other parameters. This third one will be generated, and by again third one, again I will take one more 5 by 5 and I will take convolution with 5 by 5 kernel, and I will store this value, isn't it? This is the procedure which we discussed, isn't it? We convoluted with this, and the third one was generated, first one, second one, third one, similarly, so on and so forth. That's what I am repeating actually. Just see here what's happening. This one I am keeping first time and convoluting, keeping some value, again 5 by 5, keeping some value, again 5 by 5, convoluting and keeping, so on and so forth. So effectively this kernel, which kernel? 3 by 3 cross kernel, this kernel, this convolutional filter, this 3 by 3 convolutional filter is being generated. Look at this directly. It been convoluted by applying the convolutional operation. Just what I am doing, this 3 by 3 operates this part, isn't it? Which one? This one will operate here, isn't it? What happens here? Just see. here 3 by 3 means what? By applying in layer 2, I have 3 by 3 kernel. This 3 by 3 kernel will operate on output of the layer 1. Output of the layer 1 is image. Second, let me say that is image 2. Just with these 9 pixel, this 3 by 3 means what? This 3 by 3 kernel means this 9 pixel in the output image, isn't it? But if you look at from the perspective of the input image, there is much larger area here. Just see, in the input image you are taking 5 by 5, isn't it? Much larger area here of pixel which are contributing. These 5 by 5 convoluted pixels are contributing for 3 by 3 convolution, isn't it? Because this whole thing, this input image convoluted with 5 by 5, isn't it? To generate this output image, to generate this, and again I am using this 3 by 3 kernel with this particular output image, isn't it? Yes, this is output to generate this output image. This is much bigger one. Which one is much bigger one? This one is much bigger one, isn't it? So if you look at the effective receptive field, of this kernel, which kernel I am discussing about effective receptive field for 3 by 3 kernel, isn't it? The effective receptive field of the whole part of the image 1, of the whole part of this image, the effective receptive field. Let me explain. The effective receptive field of this whole part of this image, which image? Input image, which are indirectly or directly contributing to these pixels. Which pixels? This pixel. This is contributing to this, indirectly or directly contributing to this output image, which is being convoluted. So receptive field, basically, simply speaking, is the region of the image which a kernel is being operated, isn't it? What is the receptive field? This is kernel. What is this one? Effectively, receptive field becomes important when you have multi-layer convolutional neural networks. That I will discuss what it says. Just understand like this. Receptive field, basically, simply speaking, is the region of the image. This is the region. Just see, this is the region of the image. Which a kernel is being operated, isn't it? This is the region of the image. This kernel is operating. This is known as receptive field, isn't it? At any given time. Effective receptive field, isn't it? Now we are interested in understanding effective receptive field becomes important when you have multi-layered convolutional neural networks. Multi-layered convolutional neural network, wherein multi-layered convolutional neural network means wherein second layer, third layer, fourth layer, etc., isn't it? The effective region of the original image, the effective receptive field is the effective region of the original image whose pixels, which one is original image here? Your input image is original image. This is original image, isn't it? The effective region of the original image whose pixels have directly or indirectly contributing this convolutional kernel. Which convolutional kernel? This 3 by 3 convolutional kernel, isn't it? Why is this indirectly contributed? Why? Because this first one, what is this first one? Part of input image, isn't it? An input image, what you are doing here, you are taking this 5 by 5 cross kernel. By that only you are generating pixels in this output image. Indirectly they are impacting this convolution. Which convolution? For second kernel, whose size is 3 by 3, isn't it? Because of first kernel got convoluted with 5 cross 5 to generate this first image is convoluted with 5 cross 5 to generate pixels in where? In this output image. This is now getting convoluted. These pixels are now getting convoluted with this 3 by 3 kernel. All these pixels are contributing directly or indirectly to this convolution. Which convolution? This 3 by 3 kernel convolution with this 3 by 3 part, isn't it? That's why the effective receptive field is much larger. The effective receptive field is much larger in the original image, isn't it? In original image, just we are saying that 5 by 5. That's all. This is very simple concept. The terminology is something that we have not used as part of course videos, but it is simple. You can find this in most of the textbooks. Just I request all of you to listen this lecture once or twice so that you can understand. If you have any difficulty, please keep a comment. Just it is simple and straightforward. Actually, in the case of receptive field, what is receptive field? This is the region, isn't it? Just this is the kernel. This kernel, you will convolute this in actually if you go back and see just see what we were saying. Let me go back. In medical terminology, we are saying some images. See, this is receptive fields, isn't it? In medical terminology, this one is receptive field. We are saying this is one receptive field, this is one receptive field. In similar manner here also, what's happening? An input image, your kernel, let me say 5 by 5 cross 5 kernel, in which region it is operating, that is receptive field. Again in another region it is operating, that is another receptive field. Again in another region it is operating, it is another receptive field, isn't it? That's what, just see. One receptive field, other receptive field, other receptive field, isn't it? But effective receptive field comes, where will it come? In the case of multi-layer convolutional neural network, isn't it? If you have first layer, second layer, third layer, just see, effective receptive field becomes important when you have multi-layered convolutional neural network, whereas your second, third, fourth layer. That's what I'm saying here. In the case of effective receptive field, we are saying this about this kernel. With respect to of this particular kernel, we are saying effective receptive fields. In the respect of this layer 1, first layer kernel, we are saying just receptive field. In the case of second layer kernel, we are saying effective receptive field. It's simple. If you apply this one, if you apply this particular kernel, 5 cross 5 kernel on this particular image, this portion is receptive field. Again if I apply here, again on 5 cross 5, this is receptive field. Again if I apply here, this will be receptive field. Again if I apply here, this will be receptive field, isn't it? After convoluting, you will generate pixels here, isn't it? You will generate pixels here. Just again I am taking 3 by 3 regions here and I am convoluting with this 3 by 3 kernels, isn't it? That's what it says. Effective receptive field, the effective region of the original image whose pixels are directly or indirectly contributing to the, whose pixels are contributing to the 3 by 3 convolution kernel. Here indirectly or directly, which one are contributing? This is contributing for this convolution, this 3 by 3 convolution with these pixels. Just try to go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.